of monomials. For example, if we were given the fraction 30 over 48, you would first want to try to reduce this. And you would want to find what the biggest number is that goes into both of them. You know that you can divide each of these by 6. So 6 divided by 30 is 5. And 6 into 48 is 8. So this reduces down to 5/8. That's something that you should remember from prior years. What if I did the same thing except for I put in some variables? Okay, well first we would just look at the 9 and the 15. And we go, what's the biggest number that goes into 9 and 15? And that would be 3. So 9 goes into, or 3 goes into 9 3 times, and 3 goes into 15 5 times. Here's the new part for you guys. When you have variables and you are dividing them, you're really subtracting. So we know that this is a 1 and this is a 2 when we look at our x's. So let's just pretend that we just have x's left. If you would take the bigger number, which is 2, because 2 is bigger than 1, and 2 minus 1 is 1. And since the bigger number is on the bottom, so is the variable with the number. Then you look at the y's. Which is bigger, 3 or 2? 3. So 3 minus 2 is 1, and the y would stay on top because the bigger number was on top. You must remember the laws of exponents from chapter 4. Okay, you just had your test on these. The laws of exponents, if you remember, is if you have a to the n times a to the n, you know that if you're multiplying two numbers with the same base, remember you add the exponents together. It could even look like this. This would mean the same thing. Here we would add them again, and you'd have a to the n plus n. So either way it was written, with parentheses or not, you would still add them. Here we have a to the bn. This is what we call power to a power. So remember, you're able to distribute by multiplying. So these are your powers of 1s, and you would have 1 times m is m, and 1 times m is also m. Remember your third rule could be more simple. You could have power to power just like this, and you would have m times n, which is mn. However, you might see it now as a fraction. So if I had a to the m, b to the n, and then I had my power, let's say, of c on the outside, you would be multiplying these. And you have to multiply the top and the bottom. So you'd have m times c, and you have n times c. So let's do an actual example using these laws, but with just numbers. Here I just showed the general equation. Here, remember, we have the same base, so we can subtract these, and we would do 8 minus 5. Well, we know the base number is going to be on top, and 8 minus 5 is 3. And you can simplify that to 8, because 2 times 2 times 2 is 8. Let's do one with variables. We don't have any reduce the 5 with? Because this is just an imaginary 1. So 5 divided by 1 is just 5. And then you look at your common variables, and that base number is x. So we do 7 minus 3 because 7 is bigger than 3. And 7 minus 3 is 4. And so the 4 with the variable would be on the bottom because 7 is bigger than 4. Let's make this c. T to the third divided by 3, the whole thing to the power of 2. Here you have a power to a power, except there's a fraction. So remember, with the law, you have to multiply the 3 times the 2 and the 1 times the 2, because you're multiplying your bases. And I'm getting that from right here. Remember, we did c times n, c times n. So, 3, and it's only to the power. So 3 times 2 is 6, and 1 times 2 is 2. And you know that you can reduce 3 squared to 9. And then this is your final answer. Example number 3. (24s to the 4th t to the 3rd divided by 32s t to the 5th. We're going to look at the numbers first and go, okay, what goes into 24 and 32? So this reduces down to 3/4. And then we look at the s's. 4, and this is an imaginary 1, so 4 minus 1 is 3. 5 minus 3 is 2. And again, I'm keeping it with the bigger numbers where the base stays. And this is fully simplified, so this is your answer for A. B, what if I gave you 5x over 4y squared? 5/4 doesn't reduce. I'm sorry, I was going to say nothing reduces. I have to add part of the problem. So here nothing reduces, and here I have a power to a power. So the first thing you want to do is you want to distribute that 3 to everything in the equation. So we're just going to look at this parenthesis first, and then we'll multiply it with this guy over here. So we're going to have 2 to the 3rd power, y to the 3rd power, because those were 1s. 1 times 3 is 3, 1 times 3 is 3. And 2 times 3 is 6. I'm just going to bring this guy down. Now let's go ahead and multiply out 2 to the 3rd. I know that 2 to the 3rd is 8, because 2 times 2 times 2 is 8. And now there's a couple things I can do. I can cross cancel, or I can multiply across. First, I'm going to multiply across so you can see what that looks like. 5 times 8 is 40. Now, x times x to the 3rd is just xy to the 3rd. 4 times the imaginary 1 is 4. And I'm going to have x to the 6th y squared. Now I'm going to go ahead and reduce this. 4 goes into 40 10 times. 6 minus, this was a 1 right here because the 3 goes to the y. So 6 minus 1 is 5, and that will be on the bottom. And 3 minus 2 is just a y on top. And this would be your final answer. If you want to try cross-canceling, you would go, okay, 4 goes into 8 2 times, and 3 minus 2 is just 1. Here you do 6 minus 1 is 5, and then you would multiply across. So you do 5 5 times 2 is 10, and you'd have just the y left over on top. On the bottom, all of these went away, but here we had x to the 5th, and if you notice, I got, x to the 5th, and if you notice, I got the same answer. So you can cross cancel if that's easier for you, or you can multiply across and then reduce, whatever you feel most comfortable with. The last question we're going to do is a challenge question. Let's see if you can understand this one here. Usually I let my students try this on their own to see if they really get the concepts of the exponents, because it has all the rules combined. So if you want to try it first, that might be a good idea. Looking at this question, you know that you're going to look at your x's first, and you are going to have x to the n plus 1, and you are subtracting n. And I'm getting the n from the bottom here. Times, you have y here, and that's y to the n, and you are minusing n minus 1. So when you do the math, you know that these n's are going to go away, and I'm just going to have x to the power of 1 times, here you have to distribute that negative, so it's going to be minus plus. So n minus n, they go away, and I just have a positive 1.